Hi everyone, welcome to my next video where we're going to go through a independent measures t-test, okay? And just to kind of re-jog everyone's memory, this is another version of the t-test. We've already looked at the single sample t-test. This is the two sample or the independent measures t-test. What's different about this one? Well, basically now we have two groups and we want to see if they are statistically different from one another because we've treated them differently in our experiment or in our research study. So here's your basic research scenario for a two sample t-test. Here's sample A coming from population A. In this case, they're being taught by a certain method, method A. And we have sample B coming from population B, and they're being taught through another method. Maybe sample A is a morning statistics course that takes the entire class fully online. And sample B is also a morning statistics class, but they take the class in person 3 days a week. And we want to see if there's a statistical difference between the delivery method for the course. Okay, just a made-up example there. While we only have access to sample data, ultimately our hypotheses are always about populations. Okay, so two different groups. And the independent measures, or the two sample t-test, allows us to see if the two groups are statistically different from one another on some kind of variable, maybe class grade or class performance. Okay, so let me go ahead and switch screens here. I'm going to pull up an example that I would like you to walk through. Find my other slides here. Okay, hold on a second. Okay, here we go. Okay, this is a great example, and I'm just gonna put my head over here so everyone can see this. This is a great example of a two sample t-test scenario. A researcher conducts a between subjects study. That just means there's two groups and we're comparing for differences between them. Examining the effectiveness of a group exercise program at an assisted living facility for the elderly adults. One group of residents is selected to participate in the program, and a second group serves as the control. Okay, they're not getting the exercise. After 6 weeks, the researcher reports a combined score measuring balance and strength for each individual, and the data are as follows. The individuals in the program, there's 15 of them. The average fitness score after treatment was 15.5 on the test that they used. And we're given sum of squares. Okay, sum of squares is 190. The control group had 10 people, okay, a little bit less. The mean fitness score was 12, and the sum of squares for this group was equal to 120.5. Does the exercise program have a significant effect? Use a two-tailed test with an alpha level of 0.05, and then back that up with Cohen's d to measure the size of the treatment effect. So two things here. Right, this is an example of where we would be running a two sample test because we clearly have two groups. Now that requires us to make sure that we are on the page of the formula sheet that contains all of the independent samples t-test formulas. Okay, so you want to tune to that formula sheet. It's going to have all the info you need to complete this problem. What I want to do now is go through my solution. I would suggest that you try this on your own first. It's a way more effective learning strategy to try, make a mistake, possibly fail at the problem, and then watch my solution that will clarify any confusion or mistakes that might occur. That would be what I would do. But I'm going to go ahead and transition now into my solution. So feel free to pause the video and take a shot at this yourself. Otherwise, I'm about to unveil the answers. Okay, let me just go ahead here and I am going to stop sharing. I've actually wrote this out on paper. So just like previously, I'm going to be walking through this with you. Okay. So here we have our independent samples t-test. Now, the first part of computing the independent samples t-test is this S2P. Okay, this is what we call the pooled variance. Because we have two groups, we need to get a combined measure of the variability from both groups, especially when sample sizes are not equal. In our example, one group has 15 people and the other group has 10. So the group that has 15 should have more of an influence in the variability of the combined total. This is our formula for calculating the pooled variance. We simply plug in the sum of squares for group 1 plus the sum of squares for group 2, and then we divide by the degrees of freedom for group 1 and the degrees of freedom for group 2, straight off the formula sheet. Here is my calculation. 190 is the sum of squares for group 1 plus 120.5. That's the sum of squares value that was given for group 2 in the question. And then group 1, the exercise program folks, there were 15 people in that group. So if we subtract 1, the degrees of freedom there is 14. And 10 minus 1 is 9. Okay, and if we plug this into the calculator, we end up with a pooled variance of 13.5. Okay, pooled variance. An absolute necessity when you're doing a 2-sample t-test, you need to pool the variance to get a combined total for 2 groups. Okay, and it's just simple math, plug and play. Now we're going to use the pooled variance to estimate the error term. Here is our formula for calculating the estimated error of the difference between group 1 and group 2. And you can see our pooled variance gets plugged right in up top here, and then we're dividing by the sample size of group 1 and group 2. We're adding this whole chunk together and taking the square root. This is directly off the formula sheet. Okay, and here's my work. Okay, we had a pooled variance of 13.5, and then our first sample size, not degrees of freedom, sample size, make sure you're following the formula, is a 15. Group 2 has 10. Plug this into the calculator. We end up wanting the square root of 2.25. The error term is 1.5. Okay, that is our estimated standard error. It's going to go in the denominator of our t-statistic. Okay, oops, trying to get this as... Okay, here is the t-statistic for the 2-sample t-test. Up top is just the mean difference between group 1 and group 2, people that got the exercise program and the people that didn't. And then we put the error term in the denominator. We just calculated that. It's 1.5. Now on the fitness test, the exercise folks had a 15.5. The non-exercise control group scored a 12. 15.5 minus 12 is a 3.5 point difference. Divided by the 1.5 error term, we get a t-value. We obtain a t-value of 2.33. That's our obtained t-statistic for this sample difference. Okay, is it significant? Same steps. Let's go ahead and take out our t-table. Now, keep in mind the degrees of freedom for a 2-sample t-test is the total sample size minus 2. We subtract 1 from each group. So one group had 15, the other had 10. That's a combined total of 25. If we take 1 from each group, we end up with the degrees of freedom of 23. If you look on your t-table, the critical t-value for 23 degrees of freedom at the 0.05 level is a positive and negative 2.069. Here's the visual of that. If our t-statistic falls above positive 2.069, we reject the null. The exercise program had a significant impact on fitness. Same thing if it falls below. Okay, we can always look at the mean difference. It's possible that the exercise program made the participants less fit. Probably unlikely, but it could happen. We have examples of treatments that have had opposite effects before. However, any t-values in the middle here, we can't reject the null. We don't have enough evidence that the treatment was effective. Well, our t-value is 2.33, so we just kind of make it. We can reject the null hypothesis and say that the exercise program had a significant impact on participant fitness. The group that got the exercise program was significantly more fit when it was over than the group that did not. Okay, 2-sample t-test. Always calculate the pooled variance. We use that to get the error term. The error term is the denominator of the t statistic. Okay, plug and play math. Use the table to make a statistical decision about the null hypothesis. What about Cohen's d? Okay, here's our formula for calculating Cohen's d. And again, pooled variance is part of this as well. D is equal to the absolute difference between group 1 and group 2. It's 3.5 points, divided by the square root of the pooled variance that we computed in the beginning. We end up with D equals 3.5 over the square root of 13.5. That ends up being 3.5 over 3.67. And we get a Cohen's d of 0.95, saying that this exercise program has improved fitness by almost a full standard deviation. This is a large effect, okay? Very, very powerful. You would be publishing this research if your data came out this way. Now let me just show you something here. I'm gonna write these results up in APA format. Let me just make sure that this paper is as straight as possible. Okay, we had a t statistic, right? We had 23 degrees of freedom. Our obtained t was 2.33. By definition, the probability of a type 1 error is less than 5%. D equals 0.95. Okay, you'll have to do that in the stats project. That's the string of terminology. T-value, degrees of freedom, what was the obtained t? The p-value shows you whether it was significant or not, and Cohen's d is a measure of effect size. Remember, if you have a non-significant result and you don't reject the null, the probability of an error is greater than 5. Okay, so hopefully that helped. Any questions about this problem, any confusion, post to the discussion board and I will get back to you. If you are really struggling with t-tests as well, I can meet you on Skype, I can meet you on campus, we can set up an appointment maybe before class. I'm also on campus on Mondays. Let me know, but I'm here to help. Okay, otherwise, the next video will showcase the final version of the t-test, which is the repeated measures t-test. I will see you shortly.